哥。
目前我们由倾斜轴的刹车系统开始接起，因为轴承本体的放法跟旋转轴几乎是同样的，刹车系统也大概都是同样的。Now we starting the turning axis, A-axis transmission housing assembly, which we start from bearing set, also the brake drums assembly, and we're starting from now the brake drum assembly area for the turning axis, A-axis. And we'll go to adjust the brake drum run out of the A-axis. 这是 CA 轴的旋转主轴基本原理说明。它的组合过程是由新轴稳住轴承。稳住轴承、上盖跟中间，这个叫什么东西？
外环主心轴外环。
主心轴外环组成的，由这3片式的组合去控制整个最终加压之后锁紧你那个扳手就有启动扭矩那个扳手。去得到它最终适当的举动扭矩。基本原理上，它是整个厚度控制由轴承的尺寸跟最终上盖的尺寸断差。求得2到4缪的断差之后，去量测出由启动扭矩扳手去量测出60到80牛顿、65到80牛顿或是到100牛顿的启动扭矩。This is the bearing set, rotating shaft, spindle, they say, combined with the spindle shaft, a middle spacer, roller bearing, and the top flange cups assembly to get together to grinding this piece to get a -2 to 4 micron press, and then we can get a proper torque. Starting torque by this torque range. The amount of starting torque range we assume from CA-axis different can be between 65 Newton to 80 Newton start torque, and sometimes A-axis can be up to 110 Newton starting torque by this torque range measuring. Every time you have to adjust the difference of the gaps between pushing roller bearing to get your proper starting torque, less or more adjust. Sometimes you can change the size of the roller bearing to get it higher or lower to get a proper torque, and this is basically the rotating bearings set for each axis rotating and tilting axis shaft. 组合完之后的新轴，我们现在装上涡轮来做涡轮中心的校正，因为组合后的新轴需跟涡轮同心度要求非常精确，所以当你装上新的涡轮之后，校正的地方由4个尺寸、4个地方的记号尺寸来做校正2缪之内的偏板。After the bearing sets assembly, assuming a new warm wheel, put it on. Then this is the way how they make the run out of new worms assembly, and it should be very precisely the worm wheel run out in 2 micron run out according to 4 mark position writing on 4 corner, and normally this data run out should be within 1 or 2 micron for worm wheel assembly. QM320 table A 轴传动端的组装，包括整个传动端的本体、轴承预组装、轴承本体预组装、涡轮、刹车环、刹车垫片、涡杆、轴承附件、pulley里、破颈环、端盖及CA 轴压缸盖，因为有一些缺料，所以没有办法完整组装完。Now we making AX transmission housing assembly. You see the pin frame for turning axis. You see the bearing set from turning axis, including the worm wheel, worm shaft, some sealing kits bearing, supporting bearing, at the end pulley, AX transmission pulley, motor pulley, brake drums, drum rings, and all the CA axis and clamping cylinder location over here, assembly. But the clamp and clamp cylinder, we have some parts shortage, so we cannot complete. Now we are going to start all these parts assembly. 目前我们将整个刹车环锁好之后，架的平面在约刹车环内缘下方1-2厘米的地方来做整个刹车圆内径中心的调整。Now we are checking the brake drum run out by inner ID about 1-2 millimeter lower position ID, and we are checking now. And equal digger. Yeah. And we have 10 micron run out for 4 position, which the run out of the brake drum is okay. 现在我们跟 C 轴一样，把整个涡杆轴放进去，由这到底之后，由这4只 set 螺丝大概退3/4圈回转的对不起，进3/4圈到底，碰到底进3/4圈的回转量，让整个涡杆可以稍微有一点点的间隙，完成涡杆的组装。Now we are putting worm shaft into worm wheel, and by hand turning to the end of housing, slightly tighten this MA bolt, and by the side 4-piece of MA set screw touch, and you turn about 3/4 turn of each one set screw. Then you tighten those hacksaw screw M8, and then you can feel about 10 to 15 micron backlash from the worm shaft. This is adjustment of the worm shaft very easy and simple, straightforward. 现在我们把倾斜头端的皮带轮放上去，做皮带轮的安装。Now we are installing the transmission worm shaft pulley. Make the pulley assembly over here, the other side of the shaft. Also, you may, by extension ring pushing, you may get a better run out on the pulley. 现在我们叫整个pulley的编排。We're checking the pulley run out. And here you can adjust as good as you can between 10 to 20 micron run out. And this is the run out result. You see the run out, which is quite good, in 2 micron. 我们现在开始组装旋转轴的刹车压缸，开始组装的过程。Now we are assembling clamping cylinder building into the A turning axis housing, and this is the components of the cylinder assembly, right? Need to be very carefully when you assemble. 'Cause we have some air inside, so it's sometimes difficult to knock it complete in. Need some patience. 因为我们有许多空气内压在，所以在敲打钢体的时候可能会有一点困难。注意到现象，尽量避免去伤到任何 O-ring 在组装的过程。到目前为止，大概把一个钢体的4、5个零件，大部分都放进去。So far, we put 4 or 5 cylinder components into the hole. This is all about this clamping cylinder, building clamping cylinder assembly, which indicate the C-axis, same the A-axis, and clamping cylinder. Of course, we got some set screw over here for escape some air out when you're doing clamp and pressure test for this unit. 最后这个单元的部分，我们把新轴后端盖锁上，大概就完成传动轴大部应有的组装。Now we are putting the last part of transmission housing, bearing shaft, and flange sealing caps. This is, I think, the main last parts we are installed for turning axis.
係啊，我大佬有冇啦？連我擺除。
现在我们另外一部分做QM320C 轴本体的组装，所有的附件排列顺序跟它的本体。Now we are going to do the stable C-axis transmission body assembly. And you can see all the parts located, including the flange, which is been cleaned, and also the bearing set over here, and also the worm wheel, and the brakes, worm gear, housing, and bearings, some worm gear pulley, idle pulley, and the other parts, motor pulley and so on for assembly. And we are going to do that assembly or C-axis procedure. C 轴本体的轴承轴，第一个先放进去，12支 M8的螺丝还未固定。注意的是，两个通油孔，其中的一孔是有通油。First of all, we put the C-axis bearing set into the body, and you have 12 pieces of MA screw to mount. You don't need to measure anything. Only 2 oil holes. The left hand one is for oil inlet. This is for clamping rings. This clamping ring to matching on the oil hole. This is the first step of assembly. 组装的时候，侧边有一根下斗螺丝孔，对准了本体，对准本体的泄油孔，那自然的入油口就会对到 对到下面的 O-ring 通流孔，这个孔，所以现在我们把它组合起来。This hole we're matching with this oil inlet, sorry, and the other mark you can find on this side, matching to the body on this hole. So we assemble it now. Hold it back there. 现在当我们装上刹车环之后，我们用这种方式来量测它刹车环的内径偏摆是不是有在1条之内。如果是的话，我们把它12个螺丝 M8 的锁紧，确定刹车环的同心度。After we install this brake drum, and we start to using an indicator like this to make a measuring of inner rings run out of the brake drum. If the run out less than 10 micron, then you can tighten up those M8 bolt 12 piece to fix brake drum position. And this is measuring of the brake drum, which is very good. And then still good. And then then we can use the torque wrench to tighten up all these screws. Make sure the center line of the drums okay. Within 10 micron run out, coincide to the bearing shaft. 现在我们用支具把拨杆支撑端的轴承先打入。Now we are using a steel bar to pushing a bushing roller bearing into the supporting side of the worm shaft. 哇，提早啊！
你講，
你講得頭，你只講得好就提早。And this is the bearing we are put in. 这是我们放进去的滚柱轴承，后面还有一个吸扣，这是在转涡杆之前预备的动作。Before we start to put in the worm shaft. 现在介绍的是整个涡杆预阻力单元，它也有一定的规范启动扭矩，14到16公斤的启动扭矩。调整的方法是由这个螺帽 set 螺丝未锁紧之前，它的松紧达到一定的启动扭矩值之后，再做 set 螺丝的固定。Introduce this worm shaft reassembly for starting torque. You also need to measure the certain amount of starting torque between 14 kg to 16 kg starting torque force. Method of adjusting it is using this preload nut, tightness or looseness to reaching this starting torque range. After you are qualified between 14 to 16, then you are setting up this size screw to meet the requirement of the tightness for bearing starting torque of the worm shaft. 现在我们把那个尾端支撑滚针轴承的细有密封圈放进孔内。And we are now putting a seal, X-ring seal, on backside of the roller bearings to have the purpose of anti-coolant. Otherwise, coolant can be come in. And this is the seal put in. The way we put the seal. 我们现在要把涡杆单元放入 整个涡杆轴心中铸件中，再来做背系的调整。Now we are going to put the worm shaft into the housing, and by this set screw adjusting tightness of the worm shaft, worm gear, and worm wheel to get a proper backlash. By counterclockwise turning, you can see the operator is trying to put smoothly in by two hands. The other hand he's trying to holding the shaft on the other side. 慢慢的正转旋入，直到整个涡管可以顺利的进入，慢慢的进入，跟涡轮接触为止。这是做整个涡杆预先的组装程序，进入整个轴套内。几乎已经快到位了。之后我们就开始做螺丝固定跟背系调整，正常背系调整的动作。现在把传动轴的齿轮装上去，那we are putting on the worm gear shaft pulley. We are going to check the runner. 我们叫它的编导。Pulley was tightened by expansion ring. 这是有破解完破解，所以到锁入这个齿轮的时候，不感齿轮的时候，需要叫那个编导。它的编摆叫到越准越好。The runner we can adjust as good as you can. It to be within 5 micron tolerance. 可以叫到5英之内就可以。现在装上中间舵轮的破紧环，次序之后再装上中间舵轮，然后再调整传动轮跟中间舵轮的间隙。Now he's putting expansion ring of the idle pulley, and then assembly the pulley in the middle. Finally, you can adjust backlash between pulley to pulley in 0.03 to 0.04. That means between 30 to 40 micron backlash between each pulley. Now, engineer is feeding the gaps now by adjusting the middle. 你拄调中，迄个是咧调圆盘，
就是互伊即块啊，
较晚，
较晚。
你搁做一个假的动作，搁做一个，做一丝啊，搁做一丝。He's adjusting the gap between two pulley now, and this is an amount of 30 micron. Adjustment, 看着U啊。From here, he adjusts the gap between pulley. If the gap is okay, and the pulley adjust is okay. 他们两个传动齿轮跟舵轮之间的间隙大概在0.03左右。 现在是在做调整的动作。最后我们把旋转轴的盘面锁上之后，将周围的螺丝固定，做盘面中心孔校正的动作。Finally, we put the table disc onto C-axis, and now he's checking the run out of the center hole. Try to adjust it within very accurate center run out. This is one of the final step. 下一步可以了，下一步你就假装做那个偏摆两侧。Another step measuring of the table disc C-axis is the run out measuring of the disc. Of the disc top. You measure the top of the disc run out, and then if that's something not in tolerance, that the operator may need to take off the disc and to internal grinding machine to make the flatness of the table within tolerance. And this is the final stage check of the disc itself. 如果真的最后这个盘面的偏摆过大，操作者可能会把整个吸轴的盘面拆下，做内部圆筒研磨的修整，达到最后要求的偏摆量是精准无误。First of all, you can see this is the housing, and we are going to put the brake drum into it and do some run out checking. 我们现在第一个先把刹车环的部分先放进去尾端做。它有固定的有孔位置需要 check 方向性的问题。我们现在把尾座架在一个会旋转的旋转盘上面，来做尾座中心的基准校正跟刹车环的校正。因为我们需要一个回转中心之后，才能把尾座本体的中心点寻找出来，之后才能够表移上来，把刹车环同样的同心度校起来。We are using a rotary table, magnetic. Try to put the supporting casting, find the center of the casting, and then we can check the concentric between drums to the casting, concentric center line. This is what we are doing. 现在我们把整个刹车环固定紧之后，来复验它的最终精度。整个刹车环对于支撑轴内轴心孔的编摆，大概是在1条左右，这样是 OK 的。Now we are checking out the concentric result of the brake drums. It's about 10 micron run out, and which is okay. Concentrate to the casting center. And next step, we are going to assembly bearing for this brake drum run out. We are okay, 10 micron. 现在是翻面之后的后防尘盖校正。大概我们也稍微校正一下它的同心度，这是最后有一个滚柱轴承在另外一端要装上的。Now we had to turn around the other side of the supporting end, we put sealing caps on the back side. Also, we have to check a little bit of run out, and the run out is good result. And this is a sealing end cap from the other side of the supporting bracket. 我再重述一遍。当我们把刹车环支撑座的刹车环校准同心，跟本体心轴同心，也把后端的防尘环锁上，校准它的同心。最后这个支撑座的部分就是将这个滚针轴承放入。那大体上这个部分尾端支撑座就完成。The last part of this supporting housing is to put in these roller bearings into the housing, and as this unit supporting bracket unit is complete, we have the front concentric, we have the end seal caps concentric, and the last one is put on this roller bearing. Then we are complete this unit.4个多，检查4个90度，这个心轴接触面的偏白 ，run out of the supporting shaft contact surface. Better to measure as accurate as possible. 最好能在5mm以内的偏白。现在校尾端支撑轴面的偏白 ，run out of the supporting side shaft flange. For one rotation, we got as accurate as possible within 5 micron run out. 现在量测尾端支撑轴外径的偏白 ，measuring supporting end shaft OD run out. It also need to be as accurate as possible. We target with 5 micron run out for one revolution. and it's rotating 4 to 5 micron run out. One rotation. After this, we have to put a pin on the other side, also a pin to locate the shaft. 最后，如果整个精度 OK， 这里要打 pin， 对面也要打 pin， 去做尾端心轴固定、精度确认动作。当整个把外径跟端面的偏白校到5到10秒之内之后，接着就完成 pin 打 pin 的动作，2个 pin 口。After we have this run out check of this supporting end shaft, then we can put 2 pin, one over this location, the pin, and the other one, the other location, to fix the center of the supporting shaft. 接着我们把尾端支撑座、稳针轴承心轴部分组装进去。Then we put the supporting end bracket housing, including the brakes, bearing, into the supporting shaft. And this is how assembly, right? This is the assembly of the rear end. So far until now, that the whole table, rear end, the main body frame, transmission side already assembly. Next step we are going to put onto a slide, table slide, and we start the geometry checking of the table. 这样子三片的主体组装已经完成。之后我们将把这个4、5轴放到滑座上，开始做精度检查的部分。现在我们把 QM320的 table 整体组装完之后的吊法，准备把整个4、5轴吊到机器的滑座上。做主力的工作。Now we are lifting the 4 or 5 axis table like this, the whole piece, 3 piece, onto the axis table slide base for assembly the table. 这懂怎么啊？我们现在要打入一个传动端的 pin， 这个 pin 是做基准定位用的。Now we are knocking a pin underneath 8-axis transmission side before we assemble it to the slide. And this is the pin location for 8-axis. 现在我们把整个4、5轴吊到后方时平台上的4个垫块，来做基本精度的检测。Now we are putting the table onto 4 pieces of parallel block. We're starting sit and slide, and we start the measuring of the table. 接下来传动轴本身的心轴齿轮已经装上，我们装上皮带之后，装上马达板，准备做马达的组装，皮带张力的组装。After the unit on the table, next step we put belt for 8-axis the pulley already there. We have eye space. And you put the belt in, transmission shaft, and also assembly motor plate like this. Prepare mounting the motor. You see the motor plate, adjusting screw for belt tension. And this is the motor plate assembly. 当我们校完马达皮带轮的偏摆之后，我们把马达锁上去 housing 上，装上皮带，那就开始调整皮带的张力。After we install the motor A-axis and we check the run out of the pulley, install the pulley, install the belt properly onto the bracket, and we adjust the belt tension. And the belt tension should be with a belt tension meter measuring by 280 Newton to 300 Newton tension force. 皮带的张力大概有皮带张力计量280牛顿到300牛顿的力量。我们现在开始量。这是量测的方法，靠近皮带处去用声控感应。目前量起来是302牛顿。Now we got the belt tension result of 300 Newton, which is okay belt tension. So we complete this part, and next step we are going to assemble the C-axis motor into the housing. You see the motor pulley. We have run out checking and a 5 to 10 micron of the pulley and the depth, and the offset ring on the side, which we can put on the back side of the motor housing, and we are going to do that in a minute. 你可以看到我们的偏心轮，细轴马达偏心调整环，它的大小测不一样，一边是9.24，在另外一边是10.7左右，11.0左右的距离，所以它有1米半左右的偏心量，这是让我们调整马达齿轮间距的偏心轮，换英文。Now we are measuring the offset ring of the motor. You can see the offset amount. One side you have 9.2. The other side you have 10.8. It's about 1.5 millimeter offset, and then you have small and big gaps, which allow you to adjust this gap between the motor pulley and the idle pulley for C-axis. Now we start to install that. First of all, we put in the housing. You can see small side facing down, big side offset facing up, so you can have even gap in the middle, right and left side for adjusting. So he put in the housing. And now we put the motor in. Now we start to put the motor into the housing bag. Slowly. 你螺丝要放的吗？你螺丝要放的吗？
还没啊，问题是我这水无落吗？
接着我们做直把、直规、直方规的，旋转90度量测，侧面先把它敲平，0对0的数据，量测上面几乎是等于吸走工作台面的平面度，上面量测，如果有差异的话，由委座的电变去做调整，通常。经验值来说，如果差异是2条的误差，尾端做的研磨量几乎是在5条左右，它的2.5倍。这是以经验值来说，这样子的跨距跟这样子的跨距去做电片高度的调整。我们经过调整之后，现在来量测看看它基本在0度位置的。精度如何？ Now we put a square grinding bar onto C table, and we mount the screws, and we make alignment of the side 0, 0, and also you measure the top 0, 0, equal to the table flatness of C axis. For example, if you have not 0, 0, 0, 20 micron, then the way of adjusting is by taking off this supporting end spacer, this 10 millimeter spacer, you can grind a certain amount. If you have 20 micron arrow and at this distance, so normally from this distance to this distance, you have the grinding 20 micron, you have to grinding 50 micron, 2.5 times amount to make it flat. And now we are checking 0 degree square bar top and side parallelism. I can see you. So you can see from the side is 0, 0 now because we aligned it. Because we already grind the spacer, so you can see from the top it's also very precise of 4 micron right to left. You need to write down this number plus or minus, that means this side is 4 micron higher, and then we see what happened of 90 degree tilting to change from this side and downside. 下一个我们量测 mx my m prom x m prom y 的距离，这个尺寸，也就是我们现在在刚刚0度到90度的位置之后量，那倾斜90度之后，这个前后面跟这个上下面90度位置的偏差量看看是多少，可以计算出它中心位移或是倾斜的中心线倾斜的程度是怎样。Now we are tilting the table in 90 degree, A minus 90, and same bar we are measuring this position accuracy of mx, my, m prom x, m prom y accuracy, and this is what we have now. Okay. You see the measuring result within 2 micron from the side. Yeah. 你知道不能量上面的，你量哪一个面就要量哪一个面，知道吗？
对啊。
量下面才是正确同一个面子。Now we are measuring the other direction, up and down, and you also see 2 micron error, which is good. That means the center line tilting angle is very accurate. 之前我们用圆把量出来倾斜90度之后，量出来是属于细轴中心对 table 面的中心高度。现在方规上去，待会我们再倾斜 A 轴180度，量同样的地点，求出这个点到这个面属于 A 轴的中心高度，那 C 轴跟 A 轴中心高度的间距就可以计算出来。这是另外我们要量测的一个项目。And now we are measuring by square bar to make a 0 degree. Make sure the bar is 0, 0 on 2 sides, and then we use the height gauge to pick up one corner point from the square bar to the reference 0 height. And after that, we rotate the A-axis 180 degree upside down to measure the same point again, and then you cut average A center line height to the reference. And so by bar, round bar and square bar, we have 2 dimension, C-axis, A-axis, center line distance between A-axis and C-axis. This is what we are going to do now. We have a dimension like 179 This is 0 degree position of the square bar, and later we will rotate it upside down to measure the same point again to get a real A center line height. 现在我们基本上把4、5轴的台面抓准之后，就开始来做中心把A 轴中心高度的寻找，量取圆把对中心之后，高处的偏摆量是多少？找出高点出来。 Now, after the whole frame has been grinding, the table been flat by this spacer adjustment, and then we're starting to find C-axis rotation center with the bar. Of course, you have to rotate the bottom, round out within 2 micron, and see the 250 millimeter high bar on the top round out high point, and then we know which direction it can tilt. 来，建议。When we rotate it, the table, you can find out the high spot of the bar, test bar, and then you can, from there you can know the height, the center height of A tilting 90 degrees, the center line of the A axis to the tabletop piston C axis. 现在我们把整个倾斜轴旋转负90度，test bar 水平来量测它2个端点是不是等高。在等高的情况之下，我们就可以来以这个 test bar 的中心点到工作台基准面的高度来确定 A 轴旋转中心的高度是多少。Now we are tilting the turning table minus 90 degree, and we are measuring the same height on the test bar, lower position, and higher position in same line, parallel. And then we know this is the A-axis center line assumed, and then we can measure the center line height to the slide zero reference position for A-axis center line height measuring. 我们现在有用2次元高度规量取外端圆把的最高点及最低点，相对于基准面零面的高度200的距离，180的距离，我们就知道这个 A 轴的中心线高度是多少。Now we use a height gauge to measure precisely high spot to reference zero position, low spot to reference place position, and then we have the middle line, which is A center line position. We can recall. 下面我们开始做倾斜轴侧面转动箱侧面所有空油压零件的组装。接头的部分，这里可以看到它的分布是 A 轴的松刀 ，A 轴松 C 轴松，C 轴夹跟 A 轴夹，依序来说是从实物上来看 ，A 轴的松、C 轴的松跟 C 轴的夹、A 轴的夹 ，we do assembly on this components from side of the transmission housing. This is a drawing, and you can see actual parts is like this. So A axis. 之前我们对CA 轴夹松风管的配置方式可能有一些错误的拍摄，目前做一些更正，再重新一次这部分的 layout。配置是 A 松油管，C 松的油管，A 夹，这里是错误的地方 ，A 夹 C 夹的油管，可以看到这条是 C 轴 clamp 的油管。Previously, we had some arrow layout for this portion, so we have made some correction in here. Again, for this A-axis, C-axis solenoid clamp and clamp layout. This is A pressure detect, C-axis pressure detect from the 5 bar. And for the piping, we had some mistake. We make the correct again. A-axis and clamp, A-axis and clamp, which is correct. And this is C-axis, C-axis, C-axis and clamp, A-axis and clamp, C-axis and clamp, and this one is A-axis. The lowest one is A-axis clamp, A 轴的夹 A-axis clamp, and this one is C-axis clamp. This one C-axis clamp, and then this is correct. Again, A and clamp, C and clamp, C clamp, A clamp. For these portions, make the correction. Alarm detect, pressure switch, and C-axis pressure switch for detecting. 现在说明支撑端 A 轴支撑端油管的分配，这条油管是与传动端同步的 A 轴夹的油管，那这一条是 C 轴的夹的油管，接到机器的某一个部位。This is A clamp coincide with the other side clamp cable for A-axis, and this is for C-axis from the other side out. And from this supporting end, you can see I'm putting roughly this location for A-axis reference torque position. This is A reference torque, and this is the reference sensor location over here. The other position is A plus limit switch location over here, and This here over is A minus limit switch， 这里是 A 轴的正极限感应开关，这里是 A 轴负极限感应开关。刚刚这个位置是 A 轴 home 点的碰块跟 home 点的 sensor 位置。那大概的正极限碰块，负极限的碰块在大概这个位置做调整。那正极限的碰块大概是在这个位置做左右的调整。This is A plus OT top and same A minus OT top. And then we are almost okay in the supporting end for location OD stop and limit switch location. This is roughly the last parts of the assembly for the whole table. Then the rest of this table is the linear scale mounting interface and positioning accuracy majorly. 这是一个传动轴体，我们在之前组装完成的传动轴本体。我们现在来做这个本体涡轮螺杆部分，就是涡杆跟涡轮之间最重要的一部分背系的调整。怎么样运用里面4个7个螺丝去调整它整个涡杆前进后退的松紧度，达到正常的背系值。This is one of the transmission turning axis assembly, which we assembled a while before. And now we are using this unit, try to re-exercise again the most important worm wheel and worm shaft backlash adjustment. The idea is how to use this set screw adjustment in and out, push among to adjust this worm shaft, also in, out tightness or looseness to get a proper rotating backlash for the system. And this is very important for the transmission and also for rotating axis adjustment of backlash from the worm shaft. Now we see what we have over here now, the backlash amount. You can see the backlash. You can see the backlash amount is about 4 micron at the moment, which is a little bit tight for our standard. You can see he's using 2 hands try to push the screw and get the backlash. And 4 micron for this axis is a little bit too tight. Normally a new turning table, worm wheel and worm shaft, we are asking for about 6到8μ还是8μ大一条？
标准啊
8μ大一条。
一条半。
We are asking for 10 micron to 15 micron, better to be 10 micron backlash. And now obviously we are only 4 micron, that means we are a little bit too tight. The following we are going to demonstrate how to loosen it to get, for example, 30 micron backlash, and then we can adjust it back to normal 10 micron. And then you got the idea of how to adjust this unit. 目前我们先把端盖的4只螺丝稍微的松开，之后我们要来调整4个 set 螺丝往前进1圈半的距离，越准越好。每一次旋转 set 螺丝的时候，请注意平均转入的距离越精准越好。Now we are going to loosen those end cap MA screw. 1, 2, 3, 4, and then we are going to examine the set screw turning in. Each set screw evenly we turn 1.5 revolution in. That means after you re-tighten the MA end cap screw, the whole unit of one shaft will come out. Come out is looser. So see how much we have this change after, from 4 micron maybe to 15 micron something. And this is the adjustment exercise we are going to do. Like, yeah, 转得很明显这样子，慢慢转。You can see he's turning half turn. One moment. He's how 3/4上来了，真的，来可以小。One turn. 不看的，真的。
安尼手错，安尼要紧绷啊。
1.5 turn， 我因为你试过吗 ？Half turn, 1 turn, 1.5 turn. Half turn, 1 turn, 1.5 turn. Same. 半圈、1圈、1圈半，之后我们再一次的把端盖螺帽螺丝锁紧来，这里是锁紧之后，我们再来做一次量测，看看它的变细是不是变松了。
选出来螺丝无够长，爱换。我换螺丝来。
我们再一次的平均把外端的端盖螺丝锁紧，这是进了 set 螺丝1圈半之后的变化量。平均的分2次、3次把端盖螺丝锁紧之后，接着我们再来量测一次，看看目前的变化量的被细值是多大。同样的，我们在做同样的动作，用手扳来看量表的变化量。Again, after this adjustment, we check the backlash, see how much it happened. You can see the backlash is about 25 micron now. 2条半，那个3条，是2条8，是不是？
差不多。
It's about 28 micron change, which is a little bit big of this backlash. So you can see this is the changes of the backlash. If you make the set screw in more, then you have a big backlash, which is for this unit is too big. So now we do adjust again to adjust from 28 micron back to 10 micron maybe. And we are doing it again from here. 所以我们现在看出大概是1圈半可以产生2条半的变化量，所以我们重新再做一次 新的设定调整背系。我们现在的做法是要把 settle 螺丝退出来，大概将近3/4圈的量，应该可以接近1条到1条半的背系。所以看操作者目前先再一次把端盖螺丝松脱，那再来做第二次背系的调整。这一次调整的方法是要把 settle 螺丝往后退，平均退大概3/4圈的距离。And now, again, as you see, we are loosen the end cap screw again, and this time we are adjusting the backlash tighter. Tighter. 来，开始。3/4圈，退出来，也退出来。You see, half turn, half and quarter, 3/4 turn, half and 3/4 turn, half, 3/4 turn, 半圈，3/4圈，平均的量。之后我们再重新一次把端盖螺丝锁紧，再来看它的变化。Again, we will tighten 平均的锁 evenly 2-3 times the end cap screw, and we see the new backlash again. You can see the backlash now is about 18 micron, 差点倍哈。The backlash now is about 15 or 18 micron. You can see smaller backlash, and this is the backlash amount very close to our standard. Maybe another quarter turn adjust. You can make the backlash in our spec. 可以看到目前新的调整背系从2条8大概到1条8，所以3/4圈的量大概会产生1条的背系变化，只是一个参考数值，希望能够由自己动手的经验去取得更精确的背系量调整。大概这个就是基本上 QM320 传动轴跟旋转轴涡轮涡感系统背系调整的基本方法。